Hey folks, we are back to wrap up the entire unit on similarity, and we're going to finish the lesson on proportions and triangles. So a quick recap. What have we already discussed? We've already discussed the side splitter theorem about me telling jokes. We've discussed the corollary to the side splitter theorem, and now we're going to talk about the triangle angle bisector theorem, which is a cool theorem, but it can be dangerous if you're looking at it the wrong way. So let's go to the notes. We want to make sure we're looking at it in the right way. So what's going on with the note here? If we have a triangle, and in that triangle, a ray is bisecting one of the angles. That's what's happening right here. Okay, so a ray is bisecting an angle. That's what's occurring right there. Then it divides the opposite side into two segments that are proportional. So it divides the opposite side into two segments that are proportional to the other two sides. So this and this being proportional with this to this. And that is what the note is saying. So clear cut, true. But just like in the other two videos for this lesson, you can see proportionality in different ways. Aside from looking at C and D to D and B, we can look at other things. But before I do, I want to caution you. There is a danger in this theorem, because we see a triangle with an angled bisector, and all of a sudden we see two other triangles. Be very, very cautious. This does not make similar triangles. It just makes proportional segments. So we have to make sure we're understanding a thing. This does not mean that these two triangles are similar to one another. Okay, so be very, very cautious on that. We are not making similar triangles. We're just making proportional segments. Okay, huge warning. Ignore that warning at your own peril. All right, anyhow, we have not similar triangles, but we do have proportional segments. So aside from the segments that we see being proportional, we could look at things a different way. We could look at CD to CA. We can look at it that way. CD to CA. That would be equal then to DB to BA. Okay, so we can look at it that way as well. What did I say? DB to BA. And as you can see, it's just like the equivalent proportions, but I do want to emphasize that there are multiple ways to look at proportions, not just one. And again, the caution on this correlate doesn't make similar triangles, just proportional segments. Okay? Okay, so the triangle angle bisector theorem at work. Here's a diagram with numbers and letters and x's. Yay! What's the value of x in the diagram at the right? Well, what is going on? Remember, we are not dealing in similar triangles. We're just dealing with proportional segments. Okay? How do we know they're not similar? Because the reflexive property, but you'll figure that out. We have here an angle bisector. If that's the angle bisector, what is going on? We have a lot of different proportions we could now see. If that's an angle bisector, we could look at x to 18 and 12 to 10. We could look at that. X to 18 and 12 to 10. We could look at x to 12 and 18 to 10. We could look at x to 12 and 18 to 10. And again, here we go again, dude. It's cross products are going to be the same. Product of the extremes, 10x. Product of the mean, big number. Okay, 18 times 12, whatever that turns out to be. I'll show you a trick. So we have some stuff going on. Either way, what we're going to do is solve for x. It doesn't matter how you view it. Just make sure you are viewing it correctly. Okay? So cross products. Products of the means, either way, 10x, and the product of the extremes. The product of the means, 12 times 18. Well, check this out. 6 times 12 is 72. Why is that important? Because 72 plus 144 gives me the answer, 216. So 12 times 18 is 216. All right, so there's that. How did I do that, by the way? Hopefully you figured that out. I know my 12s. 12 times 12 is 144. Leaves 6 other 12, so 6 times 12 is 72, plus 144. Anyhow, if you don't get it, use your calculator. It's fine. Cool. I should spend more time on that stuff. Either way, you find out the value of x is 21.6. Okay, but the the cross product is not the important piece. The important piece is setting up your proportion. And remember, these are not similar triangles. These are just proportional segments. Okay? Okay. Next, and one of the last things, and we get a quick quiz. So we have the value of y in this diagram. All right, Mr. Katz, what's happening here? We have an angle bisector. Bloom, bloom. That's all we know. We don't know anything about anything else. That's all we know. With the angle bisector, we're cutting the opposite side into proportional pieces to the sides, right? So 9.6 to y, 9.6 to y would be equal to 16 to 24. 16 to 24. That's one proportion we can look at. We could look at 9.6 to 16, and that would be equal to y to 24. It doesn't matter how you're looking at it. Okay? Either way, we get 24 times 9.6 and 16 times y. So it doesn't matter what's happening. So cross products, here we go. 9.6 times 24. I really don't feel like using a calculator. So I'm going to do this longhand. 4 times 6 is 24. Carry the 2. 9 and 4 is 36. There's 38. 2 and 6 is 12. Here and there, 19. So 4, 0, 3, 2 with a point. So 230.4. So either way, you can use your calculator. 230.4 would equal 16y. Okay, so you sure you don't want to use a calculator, Ms. Katz? Yeah, I'm sure. So now we're going to divide both sides by 16. We divide both sides by 16. So I'm going to divide both sides by 16. I really don't feel like using the calculator, guys. Sorry. So I'll do some long division. 16 goes into 23 one time with a remainder of 7. 16 into 70. Is that 5? No, that can't be. So it must be 4. 4? Yep. Okay. 4 times 16, let's see, is 24, 64, 64. 4. How about that? So y is equal to 14.4. Thank goodness for easy stuff. So we find the value of y to be 14.4. So again, that's not important. You can always use your calculator. But I like keeping my mind fresh with some long division every now and then. So that's the value of y. The important thing, the angle bisector, triangle angle bisector theorem doesn't make similar triangles. It just makes proportional segments. And how you set your proportion matters. So now we're going to finish with a quick quiz. I'm going to do these as fast as I can. I have not studied them in advance. So hopefully I get them right. What's the value of x in this diagram? Well, we got parallel lines going on. So you remember the old side splitter? So let's see. We got 4x to 10.5. That would be equal to 16 to 12. I'm going to do it that way. So that's 48x equals some big number there. 16 times 10 would be 160 plus 8. 168. Okay. Is that true? I hope so. Good. Does that make sense? 160 plus half of 16. Yeah, okay. And then we divide both sides by 48. So 168 divided by 48. 8 goes into that. That's something over 6. So 21 over 6. 3 goes into that. So 7 over 2. Does that make sense? Yeah, 3.5. D. True. True. So x is 3.5. I win. There's that. All right, next one. What's the value of x in this diagram? Well, we've got angle bisector theorem going on. So what does that mean? That means 12 to x would equal 9 to 24. 9 to 24. Okay, that's 3 over 8. So 12 to x is 3/8. So 3x equals 12 times 8. So x equals 4 times 8, which is 32. D. All right? Okay. And then lastly, good old 3 things cut by the deal. What's the length of site A along QZ? So here's site A. Here's QZ. We're looking for this. So I'll call it x. X to 8 is equal to 18.2 to 14. Right. So 14x equals 8 times 18.2. I would divide both sides by 14. So let's see. 2 goes into that. 9.1 times 8. 72.8 over 7. So that's, let's see, 1, 0, 10.4. A. All right. That's fun. So you can see how those things work. That's the quick quiz on the entire unit. You might have heard my bell signifying that 6th period has begun. So 6th period, that was you. For everybody else, that is it for the entire unit on similarity. Look at how much proportions come into play. It's all about proportionality. I'll see you guys on the flip side.